Good morning everyone. Welcome back to the session on speed, time and distance. In the first session in the morning, I have covered for you the concept of relative speeds and trains, and in this last session of speed, time and distance, I am going to cover for you boats and stream. So speed, time and distance, this topic I have covered overall in 3 sessions. The first session that was on Saturday was for basics of speed, time and distance, ratio methods and examples. Second session that I did in the morning today was for relative speed and trains, and third is on boats and streams, and the concepts will be used overall. So relative speed concepts will be used in boats and stream also. The basic formula of speed, time and distance will be used everywhere. These are only specialized categories or topics that are there that you need to approach separately and approach in a different way, and where we have some additional concepts that go in. Okay. So boats and stream is one such concept that is based on the concept of aided motion, because when you, let's say you take a piece of wood and you throw that piece of wood in a flowing river, then along with the river the wood also starts floating, where the speed of the wood is equal to the speed of the river. The wood itself is not exerting any pressure to move, it's just moving along with the flow of the river, which is called as aided motion. So boats and stream is a concept of aided motion, something very similar to a lift or an escalator. For example, you go to a shopping mall, there is an escalator which is going up, you see a number of steps on the escalator and you go and stand on one of the steps. Now without you moving, you start moving along with the escalator and you reach up or down according to which side the escalator is moving. When you are actually standing on the escalator, you can also start taking steps along with the escalator, wherein you can go and reach the top or bottom faster. Clear? So all these things are parallel to the concept of boats and stream. Okay? So the concept goal for the class would be to understand the concept of boats and stream, and then discuss problems based on that, and then there are some very good shortcut techniques which I have created for the concept of boats and stream, which will help you solve questions within 10-15 seconds itself. Okay, so that will be very important, which you should note down and try using that while solving questions from this topic. Now first let's understand the concept of boats and streams. So let's say a river or any water source, right, always flows from the higher level to lower level. The water always goes from higher level to lower level. That is the basic concept of physics, that water always goes from higher level to lower level. So if you are going along with the flow of the water, that is why it's called going downstream. So in boats and stream we have two concepts. One is downstream, that means you are going along with the flow of the river, and if you are going against the flow of the river, that is called upstream. Right? So think about it like this: there is an escalator in a shopping mall which is coming down, right? It's a downward moving escalator and you are trying to go up on that escalator. You should not do that actually, it is risky and dangerous, but suppose you are trying to go up the escalator. As you take steps up the escalator pushes you down. Clear? That is what is happening here also. You are going upstream, you are moving forward, water is pushing you back. And downstream is like an escalator is coming down from one floor to the other and you are also coming down. That is what is downstream. So in boats and stream we have two types of motions, upstream and downstream. We have the concept of boat or any other object that is moving in the river. It could be a boat, it could be a swimmer, right? So based on the question you just observe what word they are using, accordingly understand and apply the concept. We can use the word stream, we can use the word river, right? Normally they use the word stream or river while asking a question on boats and stream. So there are some important terms that we need to understand and remember while solving questions on boats and stream. What is a stream? A stream is moving water of the river is called stream or current. Okay, so the moving water of the river is called stream or current. So speed of the current or speed of the stream or speed of the river, all these phrases mean the same thing. तो वर्ड अगर चेंज कर दे तो क्वेश्चन में आप कंफ्यूज मत होइए, ठीक है. स्टिल वाटर, जैसे लेक हो गया या पॉन्ड हो गया, जिसका वाटर मूव नहीं कर रहा है, वाटर स्टैग्नेंट है, वो स्टैटिक है, वाटर इज नॉट मूविंग, दैट इज व्हाई इट इज कॉल्ड स्टिल वाटर. So often you will see in the question they say speed of boat in still water, speed of boat in still water. What does it mean? इसके थ्रू वो बताना क्या चाह रहे हैं आपको? Speed of boat in still water is nothing but the original speed of the boat, unaided speed of the boat. Original, or you can say actual speed of the boat. This word still water, speed of boat in still water, is used in some questions. So understand the meaning of still water. Upstream and downstream, already I have shown you with the help of a diagram. If the object moves in the opposite direction of the stream, then it is called upstream. And downstream, if an object moves in the same direction of the stream, then it is called downstream. Okay, so four concepts. First important terms, one is stream, moving water of the river is called stream or current. Still water means water is not moving. Example, it could be a pond or a lake, water is not moving. So if something is moving in still water, that is the actual speed of that object, it is unaided. It is not getting assisted or it is not getting reduced by the impact of the stream. Okay, unaided, actual, original speed of the object or boat. Upstream, when something is moving against the flow of the river, and downstream when something is going along with the flow of the river. Some important formulas that we should know. So we take x, always it is the convention, take x as speed of boat or swimmer in still water. Right, speed of boat or swimmer in still water, we take it as x, and we take y as speed of the stream, speed of the river or speed of the water current. So speed upstream will become x minus y, because speed is getting reduced, you are going against the flow of the river. आप रिवर में आगे बढ़ रहे हैं, रिवर आपको हल्का हल्का पीछे ठेल रहा है, पीछे पुश कर रहा है, राइट. सो आपका स्पीड रिड्यूस हो जाता है. Speed upstream is x minus y and speed downstream is x plus y. Also understand with respect to an escalator, escalator is coming down and you are trying to go up. So you take 3 steps up, escalator pushes you 2 steps down. So actually how many steps up you have gone? 1 step. Suppose escalator is going down and you are also going down and you are walking, you are climbing down, right. So you take 2 steps and escalator also pushes you 3 steps down. So overall you have moved 5 steps down, x plus y, x minus y. Same concept gets applied in upstream and downstream. Now 2 direct formulas, important formulas, very important. Speed of boat in still water, directly we can calculate as SD, speed downstream plus speed upstream divided by 2, and speed of stream we can calculate directly as speed downstream minus speed upstream by 2. Why does it happen? You see here, we know speed downstream is x plus y and speed upstream is equal to x minus y. If you add them, you get speed downstream plus speed upstream plus y minus y gets cancelled, you get 2x, or you can say x is equal to speed downstream plus speed upstream by 2. But it is good to remember, so that in the exam you can directly solve and get the answer. Similarly here we say speed downstream x plus y and speed upstream x minus y. What if I subtract them? If I subtract, this becomes minus, minus this becomes plus. So speed downstream minus speed upstream is equal to x will get cancelled plus x minus x, we get 2y, y is equal to then speed downstream minus speed upstream by 2. See, that is how we get the formula. Speed of the boat in still water, speed of stream. So that is how we apply this concept. That is how we got this formula here. But if you remember the direct formula, it will be of great use and it will help you in getting the answers much faster without any difficulty. Alright. Now some more shortcut techniques I will be discussing later in the session, which you should note down and which are of great help for you in the examination. ठीक है, चलो. So अभी क्या करेंगे, एक क्वेश्चन बनाएंगे. A person rows some distance downstream at the speed of 12 kilometers per hour and returns the same distance upstream rowing at a speed of 8 kilometers per hour. What is the speed of the stream? Now direct formula is there. We know speed of the stream is speed downstream minus speed upstream by 2. That is why this formula is so helpful, right? And the speed downstream directly is given to you here. So what is the speed downstream in this question? 12 kilometers per hour, and upstream the speed is 8 kilometers per hour. What is the speed of the stream? So it says speed of the stream is 12 minus 8 by 2. 12 minus 8 is 4 and 4 by 2 is 2. Suppose I had to find out the speed of boat or speed of person, the person who is rowing, speed of person in still water. Or speed of the boat in still water. Now we know that formula is SD plus SU by 2. So 12 and 8 already we know. So 12 plus 8, 20 by 2, 20 by 2, that is 10 kilometers. So this is 2 kilometers per hour and this is 10 kilometers per hour. If you check, you will see very clearly speed downstream is equal to x plus y, 10 plus 2, 12, and speed upstream is equal to x minus y, 8. So we are getting back the same values, right? Just to understand all of these things, how it works in a question scenario. Remember, the formula is very helpful for you. Directly finding out speed of the person, speed of the boat in still water, and speed of the stream. How do we calculate it directly? Okay. Now we will take the next question here. A boat goes 12 kilometers downstream and comes back the same direction. If the speed of the boat in still water is 6 kilometers per hour and total time taken for the journey is 4.5 hours, what is the speed of the stream? Let's understand this question here. Boat goes 12 kilometers downstream. So let's say the boat is going from point A to point B. Total distance how much? 12 kilometers, and the boat goes downstream. So while going, it goes downstream and comes back. So when the boat comes back, while going, if it is downstream, if you are coming back, it will be upstream. So it should be understood that while going, if it is downstream, while coming, it will be upstream. It need not be mentioned separately in the question. What is the speed of the boat in still water? What is x given to you as? 6 kilometers per hour. What we don't know is y. What is y here? Not given to us. Y is not given to us. And time, the total time taken to cover this journey is 4.5 hours. 4.5 hours, or I can say here 2 into 4, 8, 9 by 2 hours. What is the speed of the stream? This is what we have to find out. Let us say, how much time will the person take to go downstream 12 kilometers? Time is equal to distance by speed. So, what is the distance here? 12. And what is the speed? X plus y. While going downstream, the speed is x plus y. What is x here? 6 plus y. We don't know what is y. So, time taken to go downstream is 12 upon 6 plus y. Now, what will be the time taken to go upstream? Distance is same. Distance is 12 kilometers. Distance is not changing. Distance is 12 kilometers. Divide by x minus y. If you are going upstream, you have to divide by speed upstream. 6 minus y. Time taken to go downstream plus time taken to go upstream. Now, total time 12 by 6 plus y plus 12 by 6 minus y is equal to 9 by 2, and we have to find out what is the value of y. So, what we can do, we can take 12 common here. It will become 1 upon 6 plus y plus 1 upon 6 minus y is equal to 9 by 2, that is 12 into the LCM of a plus b, LCM of a plus b and a minus b is equal to a square minus b square. So, 6 square 36 minus y square, correct. Now, this will become 6 minus y on top, this will become 6 plus y minus y will get cancelled, 9 by 2. So, what are we getting here? 12 into 6 plus 6, 12 divided by 36 minus y square is equal to 9 by 2. Okay. So, you can say here 144 by 36 minus y square, 144, 12 into 12, 9 by 2. So, 9 will cancel 144 how many times? 9 will cancel it 16 times, because 16 into 9 is 144, cross multiply 36 minus y square is equal to 32, y square equal to 4 or y equal to 2. It is plus minus 2, but speed can't be negative 2. So, y is equal to 2. What is y here? Y is the speed of the stream. This is our answer. Now, ideally in examination, while having answer option, we do not need to do all these things. Once we get the equation, here 12 upon 6 plus y, 12 upon 6 minus y, we will plug in the answer options and check which answer option satisfies. It will not be required all this calculation, taking LCM, solving the equation, that will not be required in the examination. The moment we see the question, we will write down 12 by 6 plus y plus 12 upon 6 minus y is equal to 9 by 2, and take the value of y from the answer options one by one, substitute it in the equation, and immediately we will get to know within 2-3 answer options itself what is the right answer for this question. Okay. So, we have seen 2 examples here. Now, let us see the previous session contest question. From the session on speed, time and distance, relative speed and trains, what is the contest question? So, Akash started from town A at 8 am at speed of 50 towards town B where his friend Ajay lives. Ajay started from town B towards town A at 9 am at the speed of 40. So, we have two towns here, A and B. So, first of all, Akash starts from town and the distance, total distance is how much? 320 kilometers. Akash starts from town A at a speed of 50 kilometers per hour. At what time? 8 am. Whereas Ajay starts at 9 am. So, let us say when Ajay starts at 9 am. So, when Ajay starts from town B the speed of 40 kilometers per hour at 9 am, that means that Akash has already travelled for 1 hour and speed of Akash is 50 kilometers per hour. So, Akash would have already covered, this is Akash would have already covered a distance of 50 kilometers. So, what will be the remaining distance between Ajay and Akash? The remaining distance will be 270 kilometers because the total distance is 320 kilometers, right. So, 270 plus 50, 320. Now, Akash is moving towards Ajay at 9 am, both of them are moving towards each other. Akash is moving at a speed of 50 kilometers per hour, Ajay is moving at a speed of 40 kilometers per hour. The distance between them at 9 am is 270 kilometers and the relative speed, because they are moving in the opposite direction, 50 plus 40, 90 kilometers per hour. So, time taken is equal to distance by relative speed, 270 by 90, that is equal to 3 hours. So, they will take 3 hours after 9 am. So, 9 am, 3 hours, 10 am, 11 am and 12 pm. So, at what time? 12 pm. At what time they will meet? After 3 hours. 3 hours after 9 am, 10, 11, 12. So, answer will be 12 pm. At what time they will meet? They will meet at 12 noon or 12 pm. That is the answer. So, again that is the application of the concept of relative speed that I have discussed in the previous session, and now we will see the contest. Swim 12 downstream at 12 kilometers per hour and upstream at 10 kilometers per hour. Find man's rate in still water and the speed of the current. Already I have discussed with you, so quickly you can solve. I think within 20 seconds you can solve and you can post the answer in the comment section. Right? Look at the question again. Think about which formula I have taught you for solving this question in today's session and how you can directly solve and get the answer. Within 10 seconds, 20 seconds maximum you can solve this question. Choose the correct answer option based on your solution and then post the answer in the comment section. Okay. So, now we will be moving to the next slide. So, the next half of the discussion here today, we will be discussing 3 techniques which are required to solve more complex questions on boards and stream, and these are formulas which help you in getting the answer in one step itself. For questions which otherwise would have taken 5, 6, 7 steps and almost a minute of solving, we can get the answer in just 10 seconds to 15 seconds depending upon how much calculation is required. If less calculation is there, within 5, 6 seconds itself you can find the answer. So, 3 techniques one by one I have on this screen here. Right now we are looking at technique number 1 and the formula there. So, what is technique 1? A man rows a certain distance downstream in T1 hours and returns in T2 hours upstream. So, when he is going, he is taking T1 hours. A man goes a certain distance from A to B. So while going downstream, the time is T1. Understand this, remember this, downstream is T1, and when he comes back, obviously upstream, the time taken is T2. The time taken to go a certain distance downstream and time taken to come back the same distance upstream is given to you. If the speed of stream is y kilometers per hour, then the speed of the man will be how much? So if the speed of the stream is given to you, how can we find out the speed of the man or the speed of the boat directly? So the formula here is this: x equal to y, where x is the speed of the man or speed of the boat, y is the speed of the river, T2 plus T1 upon T2 minus T1, where T2 is the time taken to go upstream and T1 is the time taken to go downstream. Remember always that for the same distance, time taken to go upstream will always be more than time taken to go downstream, because upstream your speed is lesser as compared to your speed downstream. Okay? So T2 plus T1, T2 minus T1. Excuse me. So here we have the direct formula. Now let us take one example question from this direct formula and see. Okay. So let us see a direct formula example here. A boat running downstream takes 12 hours to cover a certain distance, while it takes 6 hours. A boat running upstream takes 12 hours, while it takes 6 hours to cover the same distance running downstream. What is the ratio between the speed of boat and speed of water current respectively? So here, what is T1? Time taken to go downstream. Please understand, T1 is downstream and downstream is given to you as 6 hours, and T2 is time taken to go upstream. Generally remember that time taken to go upstream will always be more than time taken to go downstream. Okay? We don't know what is y is not given to us. We can't find out what is x, but can we find out the ratio of x and y? So if you look at the formula here, this formula, x equal to y into T2 plus T1 upon T2 minus T1, by using this formula without knowing the speed of the stream, we can directly tell that x by y will be equal to T2 plus T1 upon T2 minus T1. Correct? So what is T2 here? 12 plus 6 upon 12 minus 6, 18 by 6, that is equal to 3:1. So what is the ratio between speed of boat and speed of water? The answer is 3:1. If they ask you ratio between speed of stream and speed of boat, then answer is 1:3. Always read that carefully before marking the answer in the examination. Sometimes we do all the good work, calculate everything perfectly, and then in the end mark the wrong answer and get negative marks, -1/4, -0.25. So that is the worst thing to do. Correct? Let us look at the second technique. Technique 2. Speed of boat in still water is x kilometers per hour and speed of stream is y kilometers per hour. X and y is given to you. The speed of boat is given to you, speed of stream is given to you. If it takes t hours to travel downstream and come back, so t hours, total time, what is t hours? Total time to travel d kilometer downstream and come back, then the distance d is equal to, so d is equal to here t into, where t is the total time. So you go a particular distance from A to B, you go a particular distance, distance is d kilometers, You go a particular distance downstream and come back the same distance upstream, and the total time, that is time downstream plus time upstream, is equal to t. So, t is the total time here to go downstream and come back. X is the speed of boat and y is the speed of stream. So, if you put the value in this formula, immediately you will get the answer. Saves at least 5-6 steps for you and helps you get the answer within 10-15 seconds itself. That is how useful and important this formula is. So, we will take one example question here from technique 2. A man rows at a speed of 6 kilometers in still water. So, what is given to you is x is equal to 6 kilometers per hour. How do we know it is x? Because it is in still water. Okay, so all these words observe करिए बहुत carefully. Still water दिया है कि speed of the boat downstream दिया है. अगर आप इसको observe नहीं करेंगे wrong answer आ जाएगा. If the speed of the river current, that means speed of the stream. So, sometimes we say speed of the river, sometimes we say speed of the current or speed of the river current, all are same. इसमें confuse नहीं होना है. Y is equal to 2 kilometers per hour. X is given to us, Y is given to X. It takes him 2 hours to row to a place and come back. So, time is given to you as 2 hours. What is the total distance covered by the man? So, distance is equal to 2 into x square minus y square upon 2x. Distance is equal to 2 into 36 minus 4 by 2x, right. So, 2x, the x is 6 here. So, 2 into 6, 2x, 2 into 6, because x is 6, 2 will get cancelled, 32 by 6, 5.33 kilometers. What is the total distance? Now, total distance we can say is total distance, please understand here, total distance is equal to 2d, because it is going d kilometers forward and back. So, 2 into 5.33, 10.66 kilometers. Please understand here, go to in the previous format, d kilometer downstream and come back. So, then d is equal to, so d is only one side, you are going d kilometers downstream, coming back d kilometer upstream. So, total distance will always be into 2. Total distance will be, once you calculate d using the formula that I have given to you here, multiply with 2 to get the total distance. If they ask you what the distance between the 2 points that is covered, A and B, then the answer will be directly d. Okay. So, here the answer will be 10.66 kilometers in this example. Now, we will go to technique 3, third direct technique to solve question to save a lot of time for you. Very specialized kind of question, very unique type of question. You have to observe carefully what question is there, what is being asked, and which technique I will use in this question. Randomly do not start applying technique, always you learn, you note down, you practice with lots of questions, then you become perfect, then you understand. Within 3-4 seconds you are able to read and understand and know what formula will apply in this question and how fast I will solve it. Speed of boat is given to you, so x is given to you. Speed of stream is given to you, y is given to you, but what is given to you? It takes t hours more. The difference between time upstream and time downstream is given to you as t hours. So, what is t hours here? The difference between time upstream and time downstream. So time upstream is not given, time downstream is not given, but the difference, how much more, because you should know that always it takes more time to go upstream, less time to go downstream. So how much more does it take to go upstream? That is given to you as t. Then distance d will be equal to how much? So again a person is going from A to B, covering a fixed distance of d kilometers. D kilometers is a not total distance, d kilometers is the distance between A and B. He goes downstream and comes back upstream, and the difference between the time taken between upstream and downstream is t hours, and the speed of the stream, speed of the person, speed of the stream is given to you. Put everything in this formula. D is equal to t into x square minus y square by 2y. One formula and no extra calculation required, one step you will get the answer. So let us see an example question based on this formula. A boat takes 1 hour less to travel a certain distance downstream than it takes to travel the same distance upstream. That means time taken to go upstream minus downstream is equal to 1 hour. This is your t. In the formula here, this is your t, the difference between upstream and downstream. If speed of the boat in still water is 7 kilometers, x equals 7 kilometer, and speed of the stream is 1 kilometer, y is equal to 7 kilometers per hour and y is equal to 1 kilometers per hour, then what is the distance travelled downstream? Only distance travelled downstream. That means we only need to find d here, not total distance. We don't have to find 2d, just d. So all these things play a very important role while getting the answer. D equals to t. First of all, t let us substitute here, 1 into x square 7 square minus y square 1 square by 2y. Y is 1, so 2y is 2. So basically that is 49 minus 1 by 2, 48 by 2, 24 kilometers, the total the distance downstream. That means the distance between the point A and B is 24 kilometers. If they ask total distance here, if they ask suppose total distance, then it will be 2 into 24, 48 kilometers. So again you see, what are they asking in the question? Are they asking this? Keep in mind, or they are asking total distance. What are they asking in the examination? If you calculate everything, get the wrong answer, that is the worst thing to do in the examination. So in detail we have seen the different formulas, methods, direct shortcut techniques of boats and stream, understanding the concept of upstream, downstream motion, speed of boat in still water, speed of river, right. So if you see in terms of importance in the prelims examination, around 1 maximum 2 questions can come from speed, time, distance, and same is the case with mains exam. Now in mains exam there is only data interpretation. If you look at the IBPS PO mains, IBPS PO syllabus or the exam pattern, they do not use the word mathematics, they use the word data interpretation. So in prelims only we get arithmetic question, and out of arithmetic and other mathematics questions, 2 questions maximum can come from speed, time and distance. Most likely questions in banking exams, in the prelim section of any of the bank exams, most likely questions can be from trains or boats and stream, right. Most questions are from these areas only. So focus on all the concepts, go through the videos of all the 3 sessions on speed, time and distance, note down the formula separately somewhere, write down the examples discussed and try solving them once more yourself, right, and this will make sure that you understand every aspect of this topic. So now is the time for the CPP, in which I have selected 10 questions from boats and stream for you. So those who have passport access, once you hear the sound you can start solving the CPP immediately. The questions which most of you get wrong I will be discussing in my next session. So best of luck to you, solve the questions and make sure that you learn the topic well. Thank you.